Hi guys, today we're going to learn about prime factorization. First of all, write your objective to understand prime numbers and factorization. And also don't forget to write page number 3. All right, well first we need to know the difference between prime and composite. Prime means that it has exactly 2 factors, 1 and itself. Composite means it has more than 2 factors. So we're going to look at each of these numbers and we're going to decide if it's prime or composite. So in other words, we need to think about what are the factors or what numbers go into this number. All right, so 8. Well, what could I multiply to get 8? I know that I could multiply 1 and 8, and I could also multiply 2 times 4. So here are all the factors of 8, and since it has more than 2 factors, I know it has to be composite. Okay, go ahead and try number 2. First, think about what are the factors of 2. What can I multiply to get 2 as my answer? Well, the only thing I can multiply is 1 times 2. Well, that has exactly 2 factors, 1 and itself, so that would be prime. Go ahead and take a few minutes to answer the rest of these. Feel free to pause the video. All right, so now we're going to fill in the rest of these. Hopefully you've already done it. So first 12, well I know I can do 1 times 12. I know I can do 2 times 6. And I can also do 3 times 4. Well, that has a lot of factors, so it is definitely not prime, it is composite. All right, 51. Well, let's start with the obvious, 1 and 51. Now I just need to think if anything else will go in there. 51 is not one that I'm super familiar with, so I just need to think about my divisibility rules. So 2, well 2 isn't going to work because it's not even. So then I go down to 3. Well, the rule for 3 says the sum of the digits can be divisible by 3. 5 plus 1 is 6, and 6 is divisible by 3. So that means 3 has to be a factor. Well, already I have more than 2 factors, so even though I don't know what the other one is, I know this has to be composite. And actually I can just divide 51 by 3 and see what the other one is. That goes in once. That goes in 7 times, so it's 17. Then I could run down to find other factors if I wanted to, but I really don't need to because I already know if it has more than 2 factors, it has to be composite. All right, 17. Well, I know 1 and 17. Now I need to run through my divisibility rules. It's not even, so 2 is not going to work. 7 plus 1 is 8, and that's not divisible by 3. 3 is not going to work. Well, 4 times 4 is 16, so 17 I know it won't work. Let's see, 5 doesn't end in a 5 or 0. 6 not going to work because 2 didn't work and 3 didn't work. 7, 14, 21, nope. 8, 16, nope. And 9, 18, nope. 10, definitely not because it doesn't end in 0, so I'm done. The only factors are 1 and 17, so this is prime. Okay, now last, we have 1. Well, what can I multiply and get 1? It would just be 1 times 1. Well, 1 is the same number, so I don't need to write it twice. That means it only has 1 factor. So this actually is not prime or composite. It is a special case because it only has 1 factor. All right, next we're going to look at how to do a prime factorization. Basically, the goal of a prime factorization is to break down a composite number until you're left with only prime numbers. Okay, so first of all, I'm going to make sort of like a little tree branch, and I need to think about what 2 numbers can I multiply to get 30. Now, there's more than one way to do a prime factorization. Either way, or any way that you do it, you'll get the same answer. So I'm going to choose one that's a little more obvious to me, which would be 3 and 10. So I know that if I multiply 3 times 10, that would equal 30, okay? So now I look at this, one of the factors, and I decide, is it prime or composite? Well, 3, the only way I can get 3 is 1 times 3, and we don't use 1 in a prime factorization because it's not prime. So I'm done with this. I'm going to circle it to show that it is prime. Now I need to think of 10. Well, can I break 10 down? Yes. I can break 10 down by multiplying 2 times 5. Okay? Now I need to look at each of these factors. 2 is prime because it only has 2 factors, 1 in itself. It's the only even prime number, so I'm going to circle it. 5 is also prime. The only way I can get it is 1 times 5, so I'm going to circle it. I know I'm done with a prime factorization when all of the bottom branches have circles, meaning they're all prime numbers. I can't break anything else down. Now, when I write my expression out, I like to write them going from least to greatest, but it's not required. Okay, so I'm going to write 2 times 3 times 5. All right, this would be an example of a prime factorization that does not have any exponents. All right, now let's say that I had broken this down differently. I'm going to show you one more way you could have broken this down. If I had 30 and I had chosen to do 2 and 15, well, 2 is prime, so I'd circle it. I can break down 15 into 3 times 5. Those are both prime. And look, I'm left with the same answer, 2 times 3 times 5. So no matter how you break down a number, you should still get the same prime factorization. Okay, next we're going to look at exponents. Well, exponent basically just tells you how many times a base is repeated. These are the bases. So I just look and see if they're repeated. Well, this 2 is repeated, and it's repeated twice. So I write the 2, and then how many times do I see it? I see it twice. So the exponent is 2. Then I do times, then next base is a 3. Do I repeat that any? No. So that doesn't need an exponent. Technically, you could put a 1 there, but it's not necessary. Okay, and next is a 5. And I see 2 of them, so that means my exponent will be 2. So again, the exponent just tells you how many times the base is repeated multiplied by itself. All right? Now go ahead and try this one. See if you can write the expression using exponents. Okay, let's see how you did. 3, I see it twice, so that would be an exponent of 2, times 5 is the next base, and I see it 3 times, so that's going to be the exponent of 3. All right, next, we are going to look at these expressions, and we're going to decide if they are prime factorizations or if they're not. Well, the key thing here is this word prime. To be a prime factorization, every single base has to be prime. If you see a number that's composite, it can't be a prime factorization. So I'm going to first just look at each base in my expression. Well, 2 is prime, so that's good. 2 is prime, 2 is prime, 5 is prime, 7 is prime. Since every single base is prime, I'm going to say yes. This is a prime factorization, and why? Because they're all prime. Okay, so you go ahead and look at the next 2 and try to see if you can come up with a yes or a no and why. I'll give you a minute and then we'll go over it. Okay, again, I'm going to use the same strategy I used here. I'm going to look at each base and decide if it's prime or not. Well, 2 is prime, so is the exponent technically. 3 is prime, 4 is not prime, 11 is prime. Well, since I have this number, I know I could break that down into 2 times 2. So 4 is not prime. So can this be a prime factorization? No. And why? Because it has 4, which is a composite number. All right, and the last one, well, I have 2 is prime, 3 is prime, 5 is prime, and 7 is prime. What about this 4 though? Because this has a 4 too. Does the exponent matter? Does it matter if the exponent is composite? No, because remember, the exponent is just showing you how many times this is repeated, which is a 2, and that's prime. So this is a prime factorization. Yes. Why? All prime. All right, so now we're just going to practice breaking down a few numbers Go ahead and start breaking down 36 just like we did up here. And see at the end, you might have some numbers that repeat, and we're going to try to write them using exponents. So go ahead and break it down first. Now remember, you can break it down several different ways. You just need to pick one way that works. I'm going to start with 4 times 9. You could also do 3 times 12, 6 times 6. There's a couple different options. All right, 4 is not prime, so I'm going to break that down into 2 and 2. 9 is not prime. I'm going to break that down into 3 times 3. Now I have 2, which is prime, 2, which is prime, 3, which is prime, and 3, which is prime. So I'm done because I have all the bottom of my branches have prime numbers circled. Now I just need to write my expression using exponents. Well, I have a 2, but I have 2 of them, so that would be 2 to the 2nd power times, and you can also use a dot as your multiplication symbol, so I'm going to show you that. My next base would be a 3, and I have 2 of those. So exponent 2, and that's how you write an expression with exponents. If I wrote it without, it would look like 2 times 2 times 3 times 3. But I want you to get in the habit of using exponents. All right, last one, go ahead and break that down and write the expression with exponents, and we'll check it together. Now I know that this ends in a 5, so my first go-to instinct would be to break it down by 5. Now I don't know what the other factor is, so I'm just going to come over and do 135 divided by 5. 5 doesn't go into 1. It goes into 13 twice, which is 10. And it goes into 35 7 times, so this would be 27. Now I continue. 5 is prime, so I'm done with that number. 27 is not prime, so I need to keep breaking that down. 2 doesn't work, 3 does, because 7 plus 2 is 9. That's divisible by 3. So 3, and I know that's 3 times 9. 3 is prime. 9 is not. Be careful. Sometimes I get people telling me 9 is prime. It breaks down into 3 times 3. Okay, again, this is one way you could have broken it down, not the only way. However, you should have had the same numbers circled. So first, if I wrote it without exponents, that'd be 3 times 3 times 3 times 5. With exponents, 3 to the 3rd power, because there's 3 of them, times 5. All right, well, that's all for today. See you next time.